Let's see the steps needed to implement pipelines in our code. First, let's review the normal machine learning code used to train a model. This is code you've seen before, which is used to train a model to predict the cost of a home. First, you obtain and load your data. Then we go through the preparation process, where we understand missing data, we impute that missing data, we use visualizations to understand the relationships, we use histograms, we also use heat maps to understand the correlation. Then we did a bit of feature engineering to remove the highly correlated fields. Then we encoded our categorical data. And then we trained the model. And the most important piece that I want you to understand here, when we trained our model, we used 3 different learning algorithms. We had a section for linear regression. We trained the model, we ran the predictions, we evaluated the model. And then we had a section for using the random forest regressor learning algorithm. And then we had a section further down for XGBoost. For now, the code to preprocess your data, like imputing missing values, detecting outliers using histograms, understanding correlations through heat maps, feature engineering, and categorical encoding, stays pretty much the same. However, you can in the future integrate imputing missing values, encoding the data, and additional operations into your pipeline where it makes sense. But what I really want you to see is how incorporating a pipeline makes the training and learning algorithm experimentation process more streamlined, repeatable, and efficient, giving you speed to market and reducing training costs. Now let's navigate to the code for pipelines. We are updating our code to train the model in parallel using a pipeline. The code stacks multiple pipelines to find the model with the best accuracy. Notice here we are importing the necessary pipeline and learning algorithms for linear regression, random forest regressor, and XGB regressor. Next, we create the specific objects that we need for those learning algorithms. And then we add those algorithms to a pipeline. Next, we create a dictionary of labels for each learning algorithm we use. This is mainly for printing out later so that the output is easier to read and understand. Next, we loop through each learning algorithm object in the pipeline, calling the fit function. Notice the training code is centralized into one call instead of multiple individual calls. After training, we loop through each trained model to run the predictions to help us evaluate our model by comparing the actual values to the predicted ones. We use the score function to obtain the evaluation metric, and then we print out the results. And let's take a look at those results. As you can see, the accuracy for the linear regression is at 0.56 or 56%. For the random forest regressor, it is at 75%. And for XGBoost, it is at 77%. This was a quick and easy way to determine that XGBoost performs the best on our data. There are additional learning algorithms we can add to the pipeline for experimentation. Pipelines helped us to reduce our training and experimentation process to just a few lines of code. Look at how much more efficient this code is. The organization helps us build quick and efficient machine learning models. Automating this process saves us time and reduces redundant pre-processing work while making our code more efficient. I encourage you to pause the video, pull down the code, and continue to improve the efficiency by incorporating hyperparameter tuning, imputation of missing values, and encoding into your machine learning pipeline. Let us know the efficiencies you gain in the course Q&A.